Well, if a picture speaks 1,000 words, then these, the climate stripes, say it all. Devised by Professor Ed Hawkins at the University of Reading. Each stripe shows a year's global temperature relative to the average for the period. Red for warmer and blue for cooler. Global temperatures have risen by approximately 1.1 degrees Celsius since the Industrial Revolution, and it's now said to be unequivocal that that's down to human influence. Remember, the target is to limit warming to 1.5 degrees to avoid the worst impacts of climate change. But the World Meteorological Organization has said that we will hit that watershed by 2040. Heat waves and drought are becoming more intense and longer lasting. BBC analysis has found that the number of days where temperature exceeds 50 Celsius somewhere on the planet have doubled since the 1980s. In Canada, temperatures in the village of Lytton smashed the national heat record by nearly 5 degrees when a persistent high pressure formed a so-called heat dome over the area. This contributed to a wildfire that largely destroyed the village. The World Weather Attribution Network says this extreme heat was made at least 150 times more likely due to human-induced climate change. This heat wave is on top of an ongoing mega drought that has been gripping the region since the turn of the century. Not all parts of the world are heating at the same rate. In the Arctic, it's more than twice the global average. That's a process known as Arctic amplification, and it's mainly down to the rapid loss of sea ice in the region. Energy from the sun that would have been reflected back away by the bright white ice is instead absorbed by the darker ocean. That warms the sea surface and the air above it, which in turn leads to more ice melt and a further rise in temperature. Wildfires and thawing permafrost in the region also add to the release of yet more carbon, further exacerbating the warming trend. It's not only sea ice that's melting quicker, but land-based ice too, from glaciers and ice sheets. This, in combination with thermal expansion, contributes to sea level rise. Ocean thermal expansion happens as the water heats up and molecules move around faster, expanding the volume they take up. Sea level is rising by more than 3 millimetres per year, and if melting continues at current levels, we could see a rise of as much as 15 inches or 38 centimetres by the end of the century. That'll put nearly 200 million people at risk of coastal flooding. Coastal communities are also at increased threat due to hurricanes and typhoons. Although the impact of climate change on these storms is still being studied, evidence is growing they are becoming more intense with heavier precipitation and stronger winds. What we do know is that warmer air holds more moisture. For every 1 degree of warming, the air can hold 7% more moisture. The result is more intense rainfall, the kind we saw in the devastating flooding in Western Europe in July, and in Henan province in China, where a year's worth of rain fell in just a few days. When there's extreme weather, you may hear us talking about blocking patterns. Scientists think climate change is making them more common. They happen when the jet streams, those fast-moving ribbons of air circling the globe, start to buckle as the poles heat up quicker than the equator. This traps pressure systems, causing them to be blocked. So high pressure hangs over one area, making a heat wave worse, and it also blocks low pressure in another region. Do check out our previous editions of Climate Check for more explanations of our weather and how global warming is affecting it.